Yeah, divided. Okay, it's time to start. Welcome everybody. Happy to see almost full house. And my name is Sakari Poussa. I work for Intel, surprisingly. And I'll say a few words about Intel, especially in Finland and here in Espoo. I guess a lot of people know about Intel in general. We do CPUs and hardware, but we have a lot of software engineers, actually close to 15,000 software engineers in Intel. And part of that software engineering team is located here in Espoo. And what we do here is software engineering. We have been doing Linux quite many years, and everything we do is open source, or mostly open source. One way or the other, it'll be open source at the end of the day. And so in that sense, we are a fairly community-friendly office. And more specifically, what type of things we do in this office. So this is specific to Finland. In general, Intel contributes to open source, and we have some internal tools and software as well. But for the open source areas, we work here, Linux kernel and Linux graphics drivers, then cloud software, which is some of the members are here today. Then we have a web platform team who's working on the Chromium browser, Zephyr OS, which is an embedded operating system, and then some Linux networking and communication. And then we have a small sales group and HR and support and things like that. Last slide, bit more details on a Linux kernel. Mainly, the team here is working on the peripherals and power management, Bluetooth. We have a lot of kernel maintainers here in our office. And the graphics, they are focusing on the Linux drivers. And then the Kubernetes team, the cloud software team, we are focusing on Kubernetes and especially enabling Intel hardware features so they can be consumed by the cloud native applications. We're going to show some of that work in our demo session. The web team is working on the Chromium project and W3 standardization. And yeah, then the Zephyr and comms. So that's the Intel Finland in a nutshell. And before I hand it over to Lukas, practicalities. So remember to sign your name on the sheet here if you didn't already. And toilets are on the way when you came in on the left side. The bridge is full of drinks, beer, sodas, so feel free to use that. We have pizzas. What did I leave out? Enjoy.
Yeah, I think
all right.
That's it.
Good, thanks.
Can I get the mic? Should we just... Are you going to use this same laptop later?
Yes, but I think you can close if that's...
Yeah, if you come and take it, maybe charge it at the same time.
I think it's charging, but
Or, yeah.
close it.
Let's see. Awesome. So let's start this. The audio is working? Perfect. Hi and welcome everybody to this meetup of Kubernetes Finland. We're happy to host you this time. It's going to be the last one for this year. I think it's our 11th or 12th one in total here in Helsinki. But as you might have noticed, we've also expanded during this year to Turku and Tampere. So with me, I have Ani organizing this event. We have Anton organizing stuff in Turku, and Oliver doing the live streaming and organizing in Tampere. Well, so this is the agenda for today. We heard what Intel is doing. We're happy to be here. Next I'm going to do a quick-ish KubeCon recap. What happened there, what are the major themes, what to look out for as you navigate the ecosystem in the future. Yeah, come in. And so on and so forth. And also a bit about the community. How can you get involved in certain ways and participate with this. So here we have a couple of things. So new for this meetup is that when I was in San Diego last week at KubeCon North America of this year, I got some discount codes or whatever to use for getting some t-shirts and other cool things to Finland to distribute for these meetup groups. So we have this special offer here that if you, during this meetup, sign up, or in time for the next one too, but especially during this meetup, if you sign up to speak at the next session, you'll get either a pair of Rook socks, the distributed cloud native database, or a mug with cloud native. So really valuable things here. And if you want to get some of the shirts that we have in all kinds of sizes and colors and whatever, you can fill in the survey for this meetup. So what would you like to see? What do you think was good? And also, like, what would be good things to bring up during future meetups? Cool. So then Intel will have the technical talk about how to well, as the title, get more out of your cluster in terms of physical devices. So like we have Kubernetes easily recognizes the CPU, the memory, and that kind of stuff, disk space, but sometimes there's more to it than that. I won't say any more to spoil it. Then we have Sachin from Microsoft talking about Linkerd and how to use it in various ways. And finally, we have Zsolt from VTT talking about how VTT applies Linkerd and other cloud-native projects in practice. Very well. So first, a bit about cloud-native Nordics. So this is like a meta community of these meetups, where this is one of them. We have 12 in total. In all the Nordic countries. So we try to help each other in various ways. For example, this if you attended the last meetup, we had this roadshow of 2 speakers going from, during 1 week, Copenhagen, Aarhus, Stockholm, and Helsinki. So that was a lot of fun. We're growing, soon having 5,000 attendees to our meetups, or soon 6,000 members in these in total. So all that kind of activities is really nice to see from the organizer's perspective too. And I mean, it's not only here we have 4 that are organizing in Finland. there's many more of these organizers and community members that helps this all be possible. And yeah, if you're new to this meetup group, welcome. So we just hit the 900 member mark in Kubernetes Finland. In Kubernetes Finland, we will cross-post the other Turku and Tampere groups, the events. But to actually sign up for the events, you go to the respective groups, because meetup has limitations in terms of that one group should be one city. And this meetup follows the code of conduct of CNCF, Linux Foundation. In short, be nice, respectful, include everybody. So with this community work, we're doing it, making it easier to organize meetups, but also to get engaged in various ways. For example, if you'd like to speak at one of our events, you can actually go and do the same roadshow as all the other, well, the two previous speakers. We're hoping to have roadshow next time too, if possible. But there's many other things. We have a couple of projects here. So for example, we at github.com Cloud Native Noise meetups, we track basically in a set of, well, it's a set of YAML files, but but anyways, data about who's been speaking, where are the slides, and that kind of stuff. So if there you can find all the information about all the Cloud Native meetups. And that translates through a thing we call Meetup Kit. We actually use that data so we can publish it nicely on the website. So I'm gonna do a quick tour of that. And then we also have a tool which is Workshop CTL. If some of you attended in March in Helsinki here, we had a workshop, Hands-on Kubernetes 101. So we kind of used that thing there, and last time in Tampere, we had a workshop. The Tampere one was recorded, so if you missed it, you can still follow along on how to get started with Kubernetes, because there's a lot to it at the end of the day. So just showing a bit about the website. So we have a Slack, community Slack, where you can find others. Other like-minded people, and this is a way smaller Slack, so it's good in the terms that if you go to the Kubernetes main one, we have, I don't know, 60,000, I think, by this time, members. So it has a lot of activity. So if you ask a question, it might just drown in the sea of responses and other questions. So it's a good thing. You can check out our upcoming events. For example, here, if you're planning to go to Stockholm or Aarhus or whatever, and then would like to see a meetup there, there's a lot of them too. And like past meetups, check out slides. Resource now we're live streaming this event. We've live streamed the 3 past in Finland. And now, earlier this week, they did a live stream from Umeå, and we're helping each other, so we can get that thing rolling. So check out meetup groups here. All the content, we have speakers, who's been speaking, what have they spoken about, slides, links to slides. Well, those who sponsor are visible on this kind of list. So we just launched this pretty much in time for KubeCon, and oops, Linux on desktop. Let's try again. Nope. Maybe it's like trying to get whatever. It's the same every time.
You can blame the Intel graphics drivers.
Yeah, that's probably the fault. So, and just a fun, I included this from our welcome. From our myself and Casper did a talk at KubeCon now, And the site that you actually just saw is running in a Kubernetes cluster, and we've over-engineered it like totally, but this is way more than you need for a static website. But we did it actually, so it serves as an example of how you can do it yourself. So when you actually need the complexity of Kubernetes, because it's justified. So a couple of things that are coming up in the cloud native space, cloud native Nordic space. We're hoping to launch, so we have like a set of t-shirts and other things there. We're hoping to launch our partner up with CNCF and some other branding company and launch our own like this store. So today you can buy these kinds of things from the CNCF store, but did we have the Cloud Native Nordics t-shirts? Anton, did you have the Cloud Native Nordics t-shirt that we could show? Because I didn't have it at the moment. So yes, thanks. So this kind of thing with the map on the back. So these kinds of things were, and also like as rewards to speakers and so on and so forth. A lot of community links here. We have monthly recorded calls, so you can catch up with other Nordic people there. Open to anybody. The Slack available at the website. We're live streaming this to YouTube at the moment, so search for Cloud Native Nordics there, and all our source code is on GitHub. And yeah, we're looking for speakers. We're trying to also, we would like to onboard new speakers too. So if you haven't spoken before, you can talk to any of us organizers, and we'll help you on the way of getting to your maybe first public talk. And it can be intimidating at first and all that kind of stuff, but there's ways to make it easier and actually really nice. So again, if you can talk with me or any of the others in the break, and if you think you would like to do that and still get these extra pieces of swag that we have here. And yeah, roadshow through the Nordics. So what does the meetup look, or like the Finnish community look like in terms of companies? These are a good thing about like actually tracking what we do at these meetups is like we actually get these kinds of what to say, not graphs but landscapes, so that we can see who's doing stuff and who's active. And as a bonus, if you fill out the survey down there, your company can get to this kind of ecosystem members list, which is basically serves as a backlog of okay, we know these companies are using Kubernetes. They filled in that yes, we are, and but they still haven't spoken. So really, we like people to talk about their experience and share what they learned and what was also challenging. So short about CNCF and KubeCon. CNCF, the governing foundation for Kubernetes and 20 plus other projects. They help these projects succeed in various ways. For example, arranging KubeCon, which was like 12,000 plus people, really huge. Like compared to three years ago, there was 1,000 attending. So, but that's one of the things that they're doing. They're also like helping with, all the kinds of governance and documentation and helping the meta stuff be in place for the project to succeed. And at the moment, we have these kinds of projects in the CNCF, Kubernetes, the most famous one, but also great other ones like Prometheus. That's a monitoring aggregator for metrics, and Envoy, cloud native load balancer proxy. And CoreDNS is a super simple, really nice DNS server. It does one thing. You give it a config file, it serves DNS requests. Very simple, but like I've used it many times and it's really great. Containerd is the part, like if you're ever using Docker, you're actually using Containerd under the hood. So Docker is like today split into 3. So that's Docker, Containerd, and OCI. And Containerd is then the low-level thing of running being a container runtime. And finally, FluentD for logging. And this is the cloud-native landscape, or as some people like to refer to the hellscape. Well, why do we need CNCF? Well, partly because there's just so many things. So this started in the same way, kind of that we had the YAML out there in our meetups. People can check in if they like to speak or whatever. As they organize meetups, CNCF did the same thing, but for cloud-native projects. So they said anyone that wants to be in here, PR. Like add a PR with your logo and link. And then it ended up like this. So I mean, yeah, that's a lot. And if you're a company that's starting your journey, look at this and then like, how do you start? How can you even be successful with that? So CNCF then vets some of the projects, looks at their really, yeah, and I should also say that with this, that there's 3 different tiers, so graduated, incubating, and sandbox, whereas graduated is the really super production-ready state, where you can basically bet your business on this. You can do pretty much a startup on any of these and have a chance of being successful. Incubating is like good projects that have known end users in production, and but still have things to finalize before like it actually it can graduate. And sandbox are the really early stage random ideas for projects that might or might not succeed. So CNCF classifies the projects according to this and helps you make some decisions. They also do these kinds of trail maps. So you know that when you're starting, you maybe won't think about policy the first thing. First you think about containerization, then start going to CI/CD, then maybe Kubernetes and Helm and that kind of stuff. So cloud native, this is the definition taken from the CNCF site. In short, containerized applications that often have some kind of declarative API, hopefully can run anywhere. It obviously depends on the topology of the application, but anywhere. Anyways, microservices is a plus, in my opinion. It is not a requirement for containerizing and then moving your stuff to cloud native, but it can help. Loosely coupled, resilient, doing all this with automation instead of humans actually typing in stuff and being the admins, the systems can heal themselves. And all these kinds of things also in the open. Some of them are in the open that helps people collaborate in good ways. And yeah, so you can do high impact changes without breaking your stuff. So upcoming events, KubeCon is coming to Amsterdam pretty soon, end of March. Then we have China in the summer and Boston, which is the next North American one in November. But a more interesting thing is, well, depends on how you see it, but the CNCF has started doing these Kubernetes forums for places which are not well represented by this North America, Europe, China division. So now they're having an event in Sydney and Seoul this December in the coming weeks, and then all the things like, well, India in February next year, but also like they have plans for many more cities. And these aren't as big as KubeCons, with a target of well, 1,500. So it's more close to each other. So a couple of things. I'm going to upload these slides afterwards. Here I picked 4 really nice talks, some keynotes, some breakout sessions. Well, we also, if there's people here coming to speak about how their Kubernetes experience is, we also encourage them to talk about what failed, because that will help others. Here is 2 engineers from Airbnb talking about 10 ways that Kubernetes totally broke their stuff. So, or they misunderstood how it works, or something like in the way that made something fail, right? And actually, an engineer from Zalando keeps a public list of all the ways Kubernetes can go wrong as an educational, for educational purpose. I think it's case.af. And Kelsey Hightower, a legend in the cloud native space, had a really good talk that touched upon underrepresented groups, well, for example, at tech conferences, in communities. How can we include everyone in these communities and actually be respectful and do these kinds of things? I highly recommend that you check it out. Then we have Ian Coldwater, talked about how is Kubernetes security working. So, and pointed out really cleverly that the really senior engineers of Google, for example, that built Kubernetes, designed Kubernetes in a way that, well, it's not secure by default, because everybody knows that it can't be. But most people that is coming new to Kubernetes have no idea and trust the senior, the people that built it, that it should be secure by default. But because of Kubernetes, you can deploy to so many environments, and in millions of ways of configuration, there is no silver bullet. So you actually have to think about this. Yeah, it was a great keynote trying to change the mind of when seeing at the Kubernetes cluster, to look at the views from the perspective of an attacker. And Brian Lyles, co-chair of KubeCon, talked about how to start thinking more like, for Kubernetes, more like Ruby on Rails, and how we can start thinking about convention over configuration and that kind of stuff. Because now there's a lot of configuration if you're using raw Kubernetes. I won't go through all of this. I borrowed it partly from the Umeo guys, but custom resource definitions are generally available. Kubernetes, well, really to say this in a short way, Kubernetes is getting way more extensible, but also the core is getting smaller. So instead of building everything into Kubernetes, we start seeing a push to move out things. One example of this is cloud provider add-ons have now, a thing we started 3 years ago, have now finally got just physically out of the core repo. Still, there's more work to be done. Nice things about like new metrics. I don't know if, Alexander, were you doing the node topology manager thing, or is it a different? Indirectly. Yeah. So that, and yeah, more things about that. But maybe more importantly, the whole conference also kind of emphasized the community values, which we also embrace here. So, well, distributing these things, not keeping it to one single location, for example, and also distributing power, distributing everything across in the community is better than centralization. Community over product or company is a thing that the open source community also really emphasize it a lot. And we also try to at least do it here, that if you come here to speak, you talk about the tech or something other relevant, you're not selling a product. Right. Automation of a process, this is what we're doing, for example, with the Cloud Native Nordics umbrella, and also in many other ways of Kubernetes. Automate tasks that are error-prone for humans, and instead let us collaborate better. But most importantly, inclusive is better than exclusive. There's also some prior other KubeCon talks about this. Right, so we can see this as a focus on non-code contributions in terms of docs, project management, graphics, helping new users getting onboarded, visualization, like these kinds of community activities and that kind of stuff. And also merging projects when it makes sense and they have the same kind of scope. Short thing about Helm. Helm 3 is out. You don't have to worry about Tiller hijacking your cluster anymore. So that's nice. I don't have time to go through the other things in more detail, but a lot of great changes here that is good to catch up on later. So one example of a project merger is two kind of competing projects before. In CNCF, Open Tracing and Open Census merged into Open Telemetry, and is one of the testaments of that people are trying to work together, not in silos. And this lets you, well, for service meshes, but also in any other application, do distributed tracing in a way more structured format than before. And there's a great keynote here from Sarah Novotny and Liz Fong-Jones, where they also have a live demo of how to do it. Policy. So here is what I talked about earlier. Kubernetes is not secure by default. You actually need to take. So, well, and with this I mean the core, the kernel of the system. If you buy Kubernetes from someone else, their selling point is actually hardening the thing for you. So that's. But if you just like download binaries, everything is not by default locked down in all the possible ways you could think of. So for example, there's no. If you give access to the cluster to someone else, make sure that you actually, for example, with Open Policy Agent, restrict what they can do, and not just let them do whatever, or your workloads. So Open Policy Agent is a general purpose agent for doing admitting or denying requests to the API and other applications. You can use it between your applications too. They had some cool stuff about like, what is it called this? Well, now I forgot about it's some JavaScript thing. Anyways, another theme is GitOps. We see this more and more that people start to use Git as a centralized way of storing your things. The desired state that you want to have in your production cluster is stored in Git, and then you have some automated process that actuates that into the cluster instead of giving your developers direct kubectl access and just goes ahead and imperatively doing it. So and one announcement here is that the two projects that have been doing this merged together, Argo from Intuit and Flux from Weaveworks. That was donated Flux was donated into CNCF, and now these merge because they have the same scope and it makes sense. And lastly, BPF. So this is a way to like run small parts of C-ish code at hook level in the kernel, so that you can do things like, well, there was one person that showed a kubectl trace command. So you say kubectl trace and then give a pod, and then you can actually see all the syscalls that pod is doing in real time. So you can see all the open syscalls or whatever, and then see if something's wrong with that. So there's a lot in the container security, but also you can replace pretty much IP tables or any other networking solution with that. Cool. So that's all. Mark your calendars if you are able to come to Tampere or Turku. We have Oliver and Anton are together with the other local co-organizers running these two, the 4th and 12th of December. So make sure to check that out, or the live stream also works. Thank you.
So hello everyone, I'm Ismo Puustinen. I'm a software engineer here at Intel, and this is now about our demos about what we are doing here in this office. So this is the standard disclaimer. So I think it might be too small to read the back, but the key is that we are now showing some of these Intel architecture features. We are talking about performance. So these are just measurements that we have made for the purpose of this demo. These are not official Intel benchmarks. If you want to use this, then just run your own benchmarks. And the demos are these. So first I will be talking about Envoy and how we actually accelerate TLS handshakes there. Then there will be about media transcode. Sachin and Eero will be presenting that. And then CRI Resource Manager, which will be done by Krisztian. All right, so Intel has a technology. It's called Intel Quick Assist technology, and it's an accelerator chip for cryptography and compression. It's on some Xeon chipsets, pretty recent ones, and then it's also available as a PCI card. And what we can do is that we can take some operations such as the TLS handshake, these expensive cryptographic operations, the public key operations, and actually then accelerate them on this separate chip, meaning that the CPU is then free to do something else on that time. And we have actually developed here a plugin, a device plugin, which actually scans the node for these accelerator chips and then exposes them to the containers as extended resources. And then we also did some work to Envoy proxy to actually make it accelerate TLS handshakes using this technology, and that is what we will be demonstrating here. So basically the demo is something like this. So we will have a container which runs Envoy, and then that is then getting the QAT resources from this device plugin, and then we will be showing what is the speed difference compared to this using only CPUs for doing the TLS handshakes. And there are two ways how this Envoy can actually utilize TLS and this QAT. One is via boring SSL, which is the TLS stack which Envoy uses natively. And we have actually, Intel has contributed there this technology which allows you to create Envoy extensions which open up TLS handshakes so that you can actually then use hardware features such as QAT or TPM or whatever to actually perform the actual cryptographic operations. Then there is this OpenSSL version, and OpenSSL supports already out of the box a thing called OpenSSL engines, and these engines can do these cryptographic operations such as this Intel has done this QAT engine which actually does this QAT acceleration for all or almost all software which has been written using OpenSSL. All right. Then to the demo. There's a few windows. So what we are running here is a one node. I don't have copy paste. A one node cluster which is then running this QAT device plugin there. Then I have two deployments. And one of them is with QAT and one is without. So the QAT deployment looks like this. First you will have a config map which contains this Envoy configuration. I'm not sure how many of you actually have used Envoy. Hands up. Okay, so a few. But anyway, so this is what the Envoy configuration looks like. this is where you actually tell Envoy how the TLS configuration is done. And here we are initializing our this private key provider, which is this extension I was talking about earlier, which actually lets us do QAT accelerated handshakes. Then we have configured it so that you know that Envoy is a proxy, but we are not using it as a proxy here, but we are instead just saying that whenever there's a request, just return 200. So it doesn't deliver it anywhere, it just handles the handshake and the message passing. And then the container itself, I'm not sure if you can see it on the back, but it's running in a guaranteed pod, 4 CPUs, 2 GB of memory. Then here is the resource which the QAT device plugin then is providing it. So it's getting one instance of this cryptographic acceleration. So I'll apply that. Oh. And I'll apply the no QAT version. They're running. Running there, cool. Then what we are doing for actually like the benchmarking part is that we'll be running a HTTP load generator called K6, and it will run for 10 seconds with 120 virtual users. And the configuration files, this no QAT and QAT, they only differ by the port which we are using, because so that we will hit the right service. So briefly, we'll be just creating new TLS connections and we're not reusing the old connections, and then we have specified as one very common TLS cipher suite which we'll be using. I hope I have that. Yeah. Let's run the no QAT version first.
So how many requests is this doing now?
It's running for 10 seconds. And afterwards we should be seeing that how fast it has been doing its thing. Okay. Yeah, so we'll see here that it has run something like 2,400 iterations, that many requests per second. And this HTTP rec TLS handshaking is the time it has spent actually doing the actual handshake. And we can see that 5% of these handshakes have taken more than 74 milliseconds. If we compare that to this QAT version, it's always a slight relief that it starts running at this point. Then we'll see that we actually were able to make something like 8,600 requests per second. And 5% of the requests were seeing more than 7 milliseconds. Sorry, one up, so it was not that good, but still 15. So that was the demo. Thank you everyone, and I'll let the next guy come in.
auton tästä. Slidit jälkeen.
Okay, I'm Eero Tamminen. I'm from the team doing some test loads for hardware accelerated cloud. And the one test load that I'm presenting now is media transcode. So, So this is how it works. We have a plugin which allows access to the GPU. And there are two pods. One is using accessing GPU resource from this plugin, so it runs on a GPU, and then another one running on a CPU. There's an OpenFast function as a service that is calling this service, and then there's object storage and message queue and remote file system where the videos are uploaded. And then there's a web page which is used to request these services.
Okay, so let's see how the demo works. Okay, so this is just the web application coming from the cluster, and we choose a video for the transcoding. We have some settings here, but in this case it's sending the file both for the CPU and for the GPU for transcoding. And let's see what happens. You can.
Yeah. So this file is 4K, so it's fairly big, and it's sent at the same time to both services. Hopefully FAST will schedule it at the same time and doesn't queue it for the same FAST instance.
Little bit of challenges with the function as a service scheduling. We don't control that at the moment very nicely. So in this case, we can see that they went to the same pods, even though we have multiple of them, actually two. They went to the same pods one by one, so it was kind of a sequence, so it didn't scale that well.
Yeah, but they were run on a different host. The service will report some statistics about how it ran. So it times GPU transcoding was 5.5 seconds in this case, and CPU transcoding was 17.5 seconds. This is with FFmpeg from Ubuntu 18.04 and lib x264, and this is using the Intel media driver, pretty recent one from Git, and there's it's reading from RAPL some power usage information. So there the CPU took almost 45 watts to do, per second to do this operation, and here CPU was almost unused and GPU took 3 watts. So you can see that it uses quite a lot less power and finishes much faster.
Okay.
Yes, because there are so many components involved in this particular case, debugging where the things don't go as well as they should is a bit hard. I noticed in the presentation some new advantages which might be helpful in that in the future. And by default, Kubernetes uses random scheduling policy for IP scheduling, which sometimes makes the load balance less ideal than one would hope. On transcoding, if you're going to do this by yourself, there are some pros and cons depending on which API you are using. Intel offers 2 APIs. One is VAPI, which uses the media driver directly, and then there's this QuickSync Video QSV, which uses a additional library called Media SDKs. They have some differences in features which they offer, but if somebody's interested, I can tell about that later. Any questions? Yeah?
GPU, what GPU are you using? Was it Intel's one?
Yeah, these are all running on Intel NUCs. One of them was Intel Kaby Lake GT2, and the one where the GPU encoding was done was Skylake GT4. Intel Media Driver doesn't really benefit from having a much more compute power in the GPU. Currently, it's mostly dictated by the GPU frequency, how much it gets out of it. Sorry. You had another question.
Is it the same quality, both the videos, transcoded by the CPU and GPU? Or is there a limit on the GPU?
Please repeat the question.
Sorry. So the question was, is there a difference in quality between CPU and GPU encoding? It depends on options. I haven't really compared that. In the test cases that I have done for 8-bit input, PSNR is a bit over 40, if that tells you enough. Any other questions? Okay. Anything from you?
Nope.
Yeah.
Thank you.
Hello, my name is Krisztian Litkey and I work in the same team as Ismo, basically mostly on trying to improve Kubernetes on bare metal clusters. And my presentation is about, so I don't have a demo. I was thinking about giving a demo, but then the conclusion was that probably the subject is something that you are most probably not so familiar with. So just as a quick poll, how many of you are running a bare metal Kubernetes cluster? Okay, 3. Yeah, that's what we thought. So, so maybe it's a good idea that instead of the demo, I will try to quickly rush through in my time slot on what this whole thing is about. Why are we doing this? What are the problems that we try to solve? How Kubernetes is dealing with these things, and what we are offering. And then in the end, I have a pointers basically to one much more detailed presentation by Sasha from the KubeCon last week, and basically pointers to 2 pre-recorded screencasts demonstrating the capabilities that we are having with this component. So, okay, CRI Resource Manager we have been working on this for something like maybe half a year, and we recently open sourced it, I think a month ago. So, what is the resource standing for in CRI Resource Manager? So CRI is the container runtime. What is resource? Resource in the Kubernetes world is quite an overloaded term. So almost any object that you see on the API server is in some context referred to as a resource. But what we mean by resource is basically what Kubernetes is calling a native or an extended resource. So these are typically modeling the hardware resources, CPU, memory, huge pages, devices. Ismo's presentation was actually having a couple of resources. So an extended resource was the QAT accelerator, plus it was requesting some set of CPUs and memory. So those are the types of resources that we are referring here. In Kubernetes, these are used by the scheduler to schedule your workloads to the right node so that it has enough resources. And there are 2 types of resources. There are the so-called compute resources, CPU, memory, huge pages, and this is a fixed set. So that's what is available in Kubernetes. they can be, they are so-called scalar resources, meaning that they can be sort of partially allocated. So are specifying a minimum and in a way a max, so a request and a limit, which is roughly corresponding to the minimum and the maximum, so guaranteed and maximum usage that you are that you want from that resource. Then there are extended resources. These are typically device drivers or devices like the GPU, FPGA, QAT accelerator, and they are discrete or integer resources. So you are requesting instances of them, and you cannot partially allocate them without hacks. Yeah. So Kubernetes components dealing with this resources scheduler for picking the right or a big enough node with free enough resources for your workload. In kubelet on the node, it's the node agent, CPU manager, and the container manager, which are dealing with the native resources, and device manager is dealing with the extended resources. So the CPU manager is allocating CPU, and what it can do for you is that currently it has two different configuration options. So it has two different built-in policies how it can decide which CPUs and how to allocate CPUs for you. One is the none policy, that is what is enabled by default, and as its name implies, it doesn't do anything. So then all the allocation is left basically to the Linux scheduler. So the Linux scheduler is going to freely schedule all the workloads to all the CPUs. Then there is the static policy, which is a pretty good choice if your workload nicely scales out over multiple cores, but it has no other special properties. It's not doing a lot of I/O and so forth. Yeah, and device manager deals just with extended resources. Okay, some problems which are present for bare metal clusters. So the Kubernetes model of these resources is a little bit naive. So it's very close to the idealistic von Neumann computational model where basically all CPUs are equivalent, all memory is equivalent, all the devices are equivalent. You have a pretty nice flat bus structure with infinite bandwidth. There are no caches, nothing. But the reality of a modern server is actually quite different from this. So you have memory and bus locality, you have some cores are closer to memory controllers than others. Some CPU cores are closer to PCI buses than the others. There are more than one memory controller. There is latency between CPUs and the memory controllers, and depending whether you are talking to a close memory controller or a far away memory controller, the latency is increasing. So that you have this non-uniform cumulative latency as you are crossing interconnects. And actually the situation is becoming even more such. So for instance, some of the latest CPUs that Intel is having, there is a technology called speed select, which basically allows you to permanently clock the CPU cores to different frequencies. So it's a little bit like what ARM is doing with Little Big. So then the CPUs are even becoming more unequal. And there are other resources which Kubernetes currently doesn't know about. So for instance, last level cache and memory bandwidth are two examples of something that currently you can already control via the Linux kernel, using the res CTRL file system, but this is not visible at any way at the Kubernetes level. And at the same time, what is happening that there are more and more demanding workloads. So there is a proliferation of the kinds of workloads people are trying to run on Kubernetes clusters. So some of them are extremely latency critical and require very high bandwidth. So two really good examples of those are the 5G network, Edge. There were, in the previous Kubernetes meetup at Nokia, there was a really good presentation about that, and there was a similar presentation in KubeCon last week. And there is also this, some of the automotive manufacturers are trying to offload their self-driving intelligence to the network. So the car is not doing the self-driving, it is just hitting the edge with a lot of data. Computation happens on the edge, decisions are relayed back to the car, and the car is blindly doing it. I don't want to go into that how smart idea that is, but they are trying to do it, and they try to do it on Kubernetes. So you can imagine what kind of latency requirements you are having there. Some of these problems are actively being addressed in Kubernetes with in 1.16 Topology Manager landed, and Topology Manager is a really good first step in the right direction. But for these workloads, it is not enough in its current state. So this is how, this I stole directly from Sasha's presentation. It's a really good picture in that sense that he told me not to show this because this will scare people, but that's what I wanted to do. That this is what you are dealing with in practice, yet you are having a nice uniform ideal of the server where everything is equivalent, but it's not. So this is the type of the setup that we are dealing with, and that's why we actually came up with this CRI Resource Manager. So what CRI Resource Manager is? So basically, technically, it is a proxy between the kubelet or any CRI client, so container runtime client, and the actual container runtime. So what is a proxy basically? So it is catching the requests sent by the clients and either without modifications or with modifications, sending those to the container runtime. So why do we do this? So why we do this is that we can apply extra policies to those requests. So we can modify, in a way, override what the decisions that the kubelet either made or did not make. So we have a couple of policies available in CRI Resource Manager. Basically, two of them are probably worth mentioning. So an improved version of the static policy in kubelet, which in addition to what the static policy can do is static policy can only do exclusive allocations or no allocations for a container. So this one can do shared exclusive allocations for isolated CPUs, and it also supports cache and memory bandwidth allocation using the Intel RDT technology, so basically the resource control file system abstraction of the Linux kernel. Then we have a topology-aware policy. That is basically the most complex policy currently that we are having. In a way, topology-aware is static plus with multiple topology-based pools and a couple of extra features. It can do everything what static plus can do, plus some more. So, for instance, it has container affinity and anti-affinity, which is a little bit, if you know the affinity, anti-affinity of, so the node and pod anti-affinity things or feature of Kubernetes. So this is the same thing, but within a node for containers. So one of the benefits of the CRI Resource Manager is that unlike the currently available Kubernetes policies, CRI Resource Manager opens up the full spectrum of control what is currently available in CRI and some more. So anything that you are able to do with a library or with something which the Linux kernel can do for you, you can do with the CRI Resource Manager. So basically, the basic set is so scheduler parameterization, memory limits, OM adjustment, so out of memory killer adjustments, CPU set allocation, and memory pinning. So these are which directly doable by the CRI currently, plus RDT and block I/O bandwidth control using the BLK IOC group controller, if you are familiar with it from the kernel. Okay, why are we doing this? So we would like to improve the policies available in Kubernetes. But problem with it is that in its current form, the controls are very limited there, and it is not so easy to plug in policies. So to add the new policy to kubelet, practically you are forking it. You need to take the kubelet source code, you need to modify it, and so forth. And upstreaming those changes is challenging, because especially for these kind of things. So what we are doing is mostly irrelevant for those people who are running on clusters which are not bare metal clusters. So if there is a virtualization layer Okay, so not necessarily completely irrelevant, but many of the features are not so relevant. So it's difficult to show. So we need to gather data and go back to the community with data, basically showcasing what are these changes are, how they are improving and how much they are improving the existing infrastructure. And then we can start guiding the topology manager, CPU manager, and so forth in the right direction. So it's much faster in a way to prototype with this outside of the kubelet tree than with the one inside. Plus a number of other reasons. So if you have some really strange hardware, if you have some really strange logic that is vendor or domain specific, that is not going to go upstream. But if you need it, then this is one way how you can actually plug it in. You can write your own policy. Some features which are currently not in the kubelet CPU manager, like dynamic rebalancing, you can try to do that with this thing. Or if you need control beyond what CRI offers, for instance, RDT, which we already have available in this, but if not, then you can write your own. So you can basically add something that you need, which is not currently there. Or another thing that we have out of the box there is instrumentation of the CRI interface. So if you want to see what is going on between the kubelet and the container runtime, then you can use this for that also. Finally, how CRI Resource Manager is doing what it is doing. So as I told in the beginning, it's technically a proxy sitting between the Kubernetes node agent and the CRI runtime. So we can modify passing requests, we can generate new CRI requests, or we can trigger extra local computation or any action which is outside the CRI domain, like RDT, block IO, and so forth. Anything which is doable by the Linux kernel, we can actually tap into. And some extra features like rebalancing based on collected runtime metrics. Another scary picture, so how does it look like? But not so architecturally, but I don't think it's so relevant for this discussion. And promised links. So Sasha's presentation from KubeCon, a joint presentation by Sasha and myself in Linux Peter, and 2 of the 3 demos that we have available in Sasha's presentation are behind those links.
How exactly our policies are being implemented within CRI? Does it work for generic or container runtime, or you always have to have, let's say, some runtime specific functions? Like, let's say you have run C-based runtime, right? I would expect that you can run C, well, with, say, and let's say, and within some wrapper, and let's say set some policies within that wrapper. How we will do it for, let's say, generic runtime?
So CRI has enough controls to set, for example, like CPU memory things. So,
well, like block IO.
Well, block IO is not yet in CRI, so we can control directly through C groups. So we know exactly the C group path for the container, so we can go
but
directly.
For this, you need to have some intimate knowledge of CRI internals, right?
Well,
no, you don't.
In between of it, we know about everything.
So how this works is that when kubelet thinks that it talks to the CRI, it doesn't talk to CRI, it talks to us. So to run this, you reconfigure basically kubelet to talk to.
Go back to the previous. So kubelet talks to us. We modify our request. We talk to actual container D or CRI.
Okay.
And if we can do something through this container D or CRI, we can go directly to kernel.
So simple things like changing.
Okay, let's say you talk not to, let's say use kata containers.
Yeah.
Well, you can control hypervisor allocation with policies, but you cannot control anything inside, right?
True. Well, for example, like block IO in that sense will be the whole pod. It's not that container.
Yeah. Okay.
Yeah, I think that's all I had. So if there are no other questions, then thank you. That's all what I had to say.
So let's take another break for pizza and drinks and then.
5-10 minutes, whatever. Yeah,
Can you hear me? Okay. Everything is good? All right, guys, I'm going to start. Hi, my name is Sachin. I work in Microsoft, and recently we were working with a bank in Turkey. So we used, for some reasons, a service mesh called Linkerd, and I'm just here to tell you why we used it. Now, if you have been Kubernetes community for a little while, you must have heard about service mesh. And in this year, it has become really hot. But is service mesh right for you? I don't know. There were some reasons why we decided to use it. I'm just going to explain to you what those reasons were and how we used it. But before I go forward, just to make sure that we all understand what we're talking about, I'm going to talk about Linkerd service mesh in particular. There are many implementations of service mesh. The most popular being you must have heard about is Istio, which originally came from Google. I personally think that Linkerd is much more performant than Istio is. Linkerd is also a CNCF project, unlike Istio, which is not in open governance. But they have pretty much quite similar features. And if you decide to do one over the other, the concepts should still make sense, what you take from here. So with that, I'll just start to go. So what is a service mesh? Distributed systems is hard, right? That's why we built up Kubernetes. Because if you were to build the whole system by your hand, it's tough. When we started to write applications even on Kubernetes, like multiple microservices which are talking to each other, it's very important that reliability of services is taken into consideration. So a service A calls a service B, but what if service A calls a service B and it does not respond in time? What if it is taking some time, it's not off, and you have to wait for it? What do you have to retry? You can't retry every request because not every request is idempotent. Things like these, which were network level concerns of services, had to be baked into your service code. If you think about it, you might have hundreds of services and everybody has to write that. So eventually people figured out that, okay, maybe we should just write a library which provides all of these features, and that's where Hystrix from Netflix OSS or Finnegal in Twitter came up. That's very good. Finnegal, for example, you can use, but you have to follow a certain programming paradigm. It might fit you. But what if you're not working on JVM at all? Like, what if you have some other language? And eventually there were ports of Hystrix all over the place, like for every language you can possibly imagine. But then you have to ask, why are we trying to solve network level concerns in your service code? Why don't we extract all of this and put it onto a layer, a different layer, which can then handle all of this, and your developers who are writing business logic should not be concerned about, should we retry it? How should we retry it? What's a circuit breaker like? That's the reason why service mesh was invented. So that's the reason why it was, at the start, that was a reason. And you'll notice that by providing a layer like that, we get lots of different benefits. And some of the benefits, I'll show it to you. And there are lots of features which come with it. I'm not going to go through all of that. Our next presenter will probably walk you through a little bit more of that. So service mesh, I just tried to explain to you. Linkerd is a CNCF service mesh. Pretty much similar in all of the service mesh look the same. So without going into too much detail, Linkerd is quite simple. Architecturally, it is divided into two components. One is the control plane, and one is the data plane. So control plane is, well, it controls your Linkerd deployment. It listens for when Linkerd should get activated, and then it attaches your Linkerd's proxy to your service code. So that's called the data plane. The data plane lies next to your service in a sidecar model. That is, Linkerd will observe, Linkerd's controller would observe when you apply a certain annotation, and then it will insert or inject itself next to your service as a sidecar. It will change the IP table rules of your service to route all, so it's a proxy, it will route all the traffic through itself and direct it to whatever destination it is. So that's the way Linkerd works. So it will just inject itself. It will direct all your traffic which you're sending outside or it's coming inside. So it's not only like it's proxy and a reverse proxy both ways. It's proxying, full proxy. So that's how Linkerd works. It says there's a control plane and there's a data plane. There are many different components. Maybe when I show you the pod list for Linkerd's namespace, you'll see what are the different components. I won't go into much detail. You can read about from the docs. So how do we deploy Linkerd is through Fabricate. I once gave this talk in CNCF meetup here in Helsinki. So we have this GitOps pipeline. So we, instead of writing Kubernetes manifest directly, we write it in a high-level definition. That high-level definition gets converted into Kubernetes manifest, which is observed by a Flux operator inside the cluster, and whatever we say gets applied to the cluster. So that's incidental to how we use Service Mesh. It's just you have to install the configurations for Service Mesh, and you will have to install it somehow. Linkerd comes with a nice command line. It will study your cluster, and you can generate the configs. We use that CLI to generate the config and store it in Git, so that next time when a new cluster comes up or we have to follow up what is the current cluster state, we don't have to go looking for it. Everything is in Git. Okay, so this is what I was talking about. Not going into too much detail, or maybe at this point I can just show you what the components look like very quickly. So if I was to do probably a bit small for you to see, but let's see if I can do that. So you'll just see that there is a Linkerd controller, well, destination, identity. So controller is the controller which looks for, which controls the heartbeat and all of the other stuff. It comes with a Grafana dashboard, so I'll show that to you later. Identity is used for mutual TLS, which also I'll show it to you later. It's one of the features which we wanted to use, and we didn't want to implement everything by ourselves. The proxy injector is what I was just alluding to, that when you give a certain annotation to your deployment or to your pod, this proxy injector is an admissions controller, so it's an admission webhook. It will listen to an incoming request, and if it sees that the annotation is there, it will just inject Linkerd alongside your service. And then there is tap to observe what's the flow of network through the mesh. And then there's the web, which is the dashboard. So that's what the components look like. Again, you can read the documentation to get a better idea of what we mean. OK, so this is what I was talking about, the sidecar. So in this, you have all you have to do is add Linkerd IO inject enabled. And the admissions webhook would notice that this is applied to the metadata, and it'll just inject it. So you don't have to do anything. It's just very transparent. You don't have to really do anything about it. You install Linkerd. It has a nice way to install it. All you have to do is apply this. It will automatically inject it, and an init container would also start up next to your service, and it'll change your IP table rules. And well, that's it. Then it'll be like you will see that instead of one pod running or whatever, X pod running, X containers running in your pod, there'll be X plus 1. So Linkerd will also get attached to that. All right. So, OK. So now we have installed it. We have services running in. What do we get out of it? So mutual TLS, if you have tried to implement TLS or mutual TLS on your own, you will realize it's not trivial. Why not trivial? Because you have to have a certificate authority. You have to make sure that when the service comes in, you get an identity. The two services get an identity, and then they must exchange the keys and make sure that they're talking to each other. Then you have to make sure that your credentials are rotated, and there is a lot of work which needs to go into maintaining a certificate authority. So with Linkerd here, we got all of that for free. So what it does is use identity pods. So that acts like a CA. When the service comes up, it gets an identity. Service B comes up, it gets an identity. Before service A tells or sends any packet to service B, they verify the identity, and everything happens over TLS. So without doing anything for ourselves, we just get TLS out for free. I'll show you how it looks if you have TLS on. It takes a little bit time for it to switch, so that's why. So Linkerd, I'm just now going to use Linkerd's command line, and I'm going to do. So what I'm saying is, show me all the edges which exists in this mesh. Edges is one service is calling another service, right? So that's an edge in between. So you will see that an ingress controller, it does not matter what it exactly is. An ingress controller has an edge to some service, and then if I was to, okay, probably not that. Yeah, so if you just look here, that's how it looks. So it's like has a green check mark which says that Both of these services are Linkerd injected, so both of them are in the mesh, and all the traffic between the two are happening over TLS. And I didn't have to do anything about it. So it's like all the traffic will be opportunistically upgraded. Not all the HTTP traffic is opportunistically upgraded to TLS for free. If you have a requirement like that, for us, it was in bank. So we didn't have to implement anything about it, which is great. All right, so any questions? Yes?
Do you support 12 stack or IPv6 traffic?
Yeah, so we are talking about Linkerd here. So yeah, so.
Can you repeat the question?
Does it support IPv6? So yeah, it just uses the Kubernetes CNI or plugin. So as long as your CNI plugins support, so Linkerd is agnostic to it. So this is provided by your network provider, or the network plugin you are using. So I'm sure, like, whatever standard network plugin you are using, even if it's KubeNet or Calico or whatever you're using, as long as that supports it, which it should, it will just work. Okay, so this was the original reason I was talking about. I won't go into much detail. So in Linkerd, what you can do is you can help Linkerd and tell it what are your different routes. And just by providing that kind of specification, which I'll just show it to you, there's some kind of specification, you can help it to retry your routes when it fails. You can specify the timeouts between retrying different things. And all of this, again, comes without you having to worry about how to implement the whole retry logic. All you have to provide is a spec that I have a route A, I have a call from A to B, and I want it to behave in this way. So you can, it's very easy to read this spec. It's like, say, for one particular annotation, for this one, it's a retry. So if Linkerd finds out that when you make a call for this one and it fails, it will go ahead and retry it. So I was saying, we don't want every call to be retryable, and you have to actually specify it, because not all calls are idempotent. It's not by default that every call should be retried. Sometimes retries should not happen. So in this case, we specify that, okay, I want retry to happen, so I just specify it. But I don't have to implement anything in my business logic. This is handled by Linkerd, which is, again, a nice thing. Again, retries at what we don't want to bombard a service when it's failing, especially when it's failing. It can have cascading failures over all your services. So you want to make sure we have a retry budget. Like in a certain period of time, how many retries do we want a service to send? So again, it's very configurable. You can just set it into your spec, and it's the same is with timeouts, like how long should I wait? In a distributed system, probably failure is easy, and slow services are the worst, because you don't know if they have failed or not, and how long should you wait for your service to return back or not. Again, it's very handled very nicely. These kind of things, again, if you're from JVM and if you're anything like Hystrix, this will sound very familiar. This is exactly how Hystrix would have used it. Like, you can specify all of this, but then you'll have to write it as part of your code. At this point, I think I'm just going to hand it over to our next speaker, because he's also going to talk about canaries. So I don't want us to repeat the content, but he'll give more information about Linkerd and about canaries. Is that okay? Maybe I'll just step in and talk about canaries. So, hey, question.
Can you do connection outside, for example, database?
Connection. Oh, you mean, so service mesh would generally be for looking at service within your cluster. So for all communication to database, you actually bypass the Linkerd proxy completely. So in the annotation, you have to actually give skip outbound port or something like that. So it will not try to proxy. So those calls would go directly to your database without going through the proxy at all, because we don't want to have them in the mesh. Okay, very quickly, canaries. It was an important requirement for this bank to make sure that every production environment does not just receive the deployment. If you know about Kubernetes deployment, they have a rolling strategy and all, that's fine. But in this case, we wanted a canary deployment. The canary is, if you don't know what a canary is, it looks something like that. So look, in one you see there you have version 1 of your service, and your traffic is directed to 2 pods of v1. So now you have an incoming deployment, and you do v2. So you get a v2 service, and now we are directing 5% of the traffic to the new v2, and the rest 95% is going to v1. And now we do checks. We want to make sure that the v2 is responding as we expected it to. And slowly, we would move 5%, 10% till a certain threshold where we think that everything is working fine. So in this case, it says like 50% of the traffic is moved to the version 2, and then everything is working fine. So what we're going to do is promote v2 to become the actual primary. So we start to remove v1 and put v2 in there, and then we remove the traffic, and all of the traffic now goes to v2. So this is how canaries work. So instead of having the deployment, we're like, okay, my deployment is there. Let's route all the traffic there and hope for the best. Probably doesn't work out that well, you know. So in this case, we want to shift the traffic slowly and make sure that everything is working. So this is what we wanted to implement. Could have done it by hand, but since we were using service mesh in this case for other reasons, we used some tools to help make things easier. Would that be a good time for you to step in? Okay. Yeah, I don't want to repeat content. So yeah, thank you. You will continue with that.
That's the safest choice. Bingo.
Yeah, before at least, yes. Okay.
All right.
Cool, let's start.
All right, let's continue. So, my name is Zsolt Homorodi. I'm from VTT Oulu, and today the presentation will be about the cloud-native components we use in the data pipelines that we are creating in our group. I try to be really short on the actual slides and then do some demonstrations along the lines, for example, using Linkerd and some deployment tools and things like that. So if somebody doesn't know what is VTT, so we are the National Research Center of Finland. We have about 2,000 researchers, and there are companies doing all kinds of research from nuclear to AI and machine learning and stuff like that. We have about 200 software projects a year, and we have about 10 to 20 projects that gather data sets for AI and machine learning scientists. And that's where we started to use Kubernetes. So inside VTT, we don't really have a dedicated operations team that we could hand over software to. But all the project teams need to own their deployments, which means that quite often teams that consist of mostly researchers who do some level of software development need to own deployed servers that are sometimes exported towards the internet. So what we came up with an idea about 1.5 years ago is to try to create a set of basic things that these researchers can more easily use, empower them in a way that they can concentrate on what they are actually hired for and don't need to spend so much time on maintaining software. And one of the other really strong motivations was the GDPR compliance. So we want to make sure that when we are gathering data, especially in projects where we are gathering a lot of health data and other sensitive things, that those won't get accidentally exposed. So what our researchers really want to concentrate on is the data, then train their models, and then expose those models to run the inference and then test how it works. But once you try to deploy it in a way that it's GDPR compliant, it's maintainable, it's monitorable, and so on, suddenly you will have a lot more to work with. We chose Kubernetes because it seemed quite, how to say, obvious that a lot of development is nowadays targeted towards Kubernetes. So we can find great tools and great components to put together our system. So just very briefly, we are mostly using gRPC to talk between our services. So this kind of gives us a requirement. So when we are collecting all the components that we want to use, one of the requirements is that they need to work with gRPC. So as you saw in the picture, one of the first components that you need to have is an ingress. We worked with Envoy before in some projects, so we wanted to select one ingress controller that uses Envoy. And in case of gRPC, an ingress controller that knows and understands gRPC is really important, because otherwise load balancing can be really tricky with the long living connections in gRPC. This component will take care of TLS termination, and there are a lot of options out there. So these are the 3 that we worked with during the development process. At the end, we selected Ambassador because it has both gRPC and WebGRPC support built in, and also it has direct support with Linkerd 2. I will show what that means exactly. And one common thing is when you are selecting and evaluating an ingress controller is that all of them offers features beyond the default ingress specification. The default ingress specification is really limited. So if you have special needs, it's worth looking through that what these extras are that are available. Then we wanted to use Let's Encrypt for our TLS certificates. So in Kubernetes, practically the default way nowadays is to use Cert Manager from Jetstack. It will take care of the certificate issuing and rolling the new certificates and so on. We wanted to have some kind of monitoring component. So that was our motivation that led us to service meshes and Linkerd. We want our researchers to concentrate on writing the application, and this was explained previously, not to think about things like retries, string strike, timeouts, and things like that. But this is what the service mesh provides us. Originally, we saw MTLS as a nice extra that comes with Linkerd, but during the project, when GDPR became more and more important, that is a really good component to secure the communication between the different service components and make sure that even when we are running most of our clusters in Azure, for example, that when the node barriers are so data goes through the node barriers, then it doesn't travel in plain format. We don't utilize much retry budget or traffic shifting or canary deployments at the moment. We are testing canary deployments. Retry budget, we cannot actually use in most of the cases because Linkerd doesn't support retries for gRPC services. Then we wanted to automate the provisioning of this thing. So we choose at the end a tool called Pulumi. So it's infrastructure of code using actual real programming languages. So it's something similar to Terraform, if you guys ever tried or used that. And some of its providers are actually generate like a proxy around the Terraform provider. But they created a really nice system. I will show some code and how it runs. So you create practically like objects, you configure them, and then you can, it understands some relationships between the objects, and you can also manually set that will like dictate the order of deployment. And they have a really nice Kubernetes provider that has 3 ways of creating resources in Kubernetes. You can do it totally programmatically. You can reuse your existing Helm charts, or you can use standalone YAML files. And one of the interesting things is, and I will show an example for that, that even for these, it parses up the data into internal object format, and then you can modify it. So you can programmatically add things or modify things inside these, like in a way like templating. And one other interesting thing it does is that during the deployment, it waits for the certain elements to be ready. So if you have, for example, a deployment, it will wait until enough pods are ready in that deployment before it goes to the next step. So when you express your dependencies, you can be certain that when the dependent object wants to do something, then its dependency is already fully up and running inside the cluster. It comes very handy, for example, if you are installing CRDs and then later you are creating instances of them to make sure that the CRD is fully installed into the cluster. And lastly, we started to use GitOps about half a year ago. We also selected Flux, it seems like the theme of the day. And we also use Wave Flagger. And then we use a third component from Bitnami Labs called Sealed Secrets. That makes it possible for you to check in actual secret objects into the cluster, into your Git repository in an encrypted form. And then during the deployment of the cluster in the Pulumi script, you define your master key that you used for encrypting the data, and that secret key will be able to decrypt it. So it uses a public key cryptography. So what is inside the Git repository cannot be decrypted by anybody, but only the cluster itself will be able to decrypt it. So, and then how it comes together in our case, this is the flow of the installation that the Pulumi script does. So Pulumi script itself creates the cluster for us. In this demo, I will be using DigitalOcean, but normally we use Azure. Then it installs Linkerd and Cert Manager together. Then it installs Ambassador. Then when Ambassador gets the external IP address, it uses that IP to register it to a DNS name. Using the DNS name, it requests a certificate through Cert Manager. When the certificate is ready, Ambassador automatically picks it up. That was one of the things why we chose Ambassador. Not all ingress controllers do automatically pick up their certificates. Then we install Flux, and then we install Flux in a way that it points to a separate Git repository. And once it installs it, it will pull that Git. Yes?
How often this happens? Is this like a once a day, or
no.
When the researcher starts a project, or?
Yes, it's more like when researchers start a project, then we don't use shared Kubernetes clusters because
so
of
gets their own cluster.
yes, because mostly this is how project financing works inside VTT. It makes it much more easy for us to create a cluster per project, and then the cost of that cluster goes to that project. So once a project starts, we create a separate Git repository for them where they put their own applications. And then we run this cluster creation and point to that repository. One of the things what we wanted to do is that we want to handle these clusters as cattle, so to say, not as pets. So anytime we find something that one of the components needs to be changed, or some special things need to be installed, we can just bring down the cluster and bring it up again. And because of the automated rules how this DNS name is created from cluster name and some various components, we always get the same DNS name back. So, and then we can point usually these projects are about some kind of data gathering, and then we are having various kinds of gateways, like your phone or some gateway devices, edge computing devices that gather this data and push into the cluster.
You do this all in the public cloud? You don't have any machines
Yes.
or clusters or machines of your own?
At the moment in VTT, we don't have any internal, like bare metal Kubernetes clusters. We actually got some funding from a local, this northern local, I don't know how it's called, anyway, a local funding instrument gave us some money, and we already have some hardware machines waiting for somebody to actually be brave enough to start doing bare metal Kubernetes clusters on them, probably early next year. One nice thing about this one is that while in this demo, the Kubernetes cluster is created in this public cloud, and they support a number of providers. One of the ways you can consume Kubernetes is that if you have your cluster, you can just point the Kubernetes provider of Pulumi to your cluster, and then instead of creating the cluster, you just install things into that cluster. Yes?
And how long is the cycle from writing code to deploying to Kubernetes? How long is it?
It depends how the researcher wishes to push the data. So as soon as you push to this repository, this component every 5 minutes checks what's in your Git repository. If it sees that something new is there, it will take it down and then practically apply it to your cluster. And because we also have Wave Flagger in the toolbox, you can define canary deployment. So if the project is like a bit more advanced, that's we are just testing at the moment. But that component, as we saw before, can take care of that. Your service is not just immediately replaced with the new version, but a canary version will come up. There is some testing going on. In your canary definition, you can define a load generator that will be used to test the canary. Does it work correctly? And if it works correctly, then it's switched over. If it doesn't work correctly, then the original version is kept. But practically, with a Git push, you are deploying services to your Kubernetes cluster. Any other questions, or shall we jump to the demo? Yes?
Do you handle Kubernetes upgrades in any way?
This system does not handle it very well. It handles it in a way that if I specify a different version of Kubernetes, Pulumi's upgrade routine is very conservative, so it won't upgrade the Kubernetes nodes. It will actually create a new cluster, deploy everything there, and then bring down the old cluster. But of course, nothing stops you to go back to the normal. And you can write your own things you can write your own providers and all everything. So, but at the moment, that is the strategy they use.
So apparently, the project is stuck with one version, and that is where you develop your application.
As I said, you can upgrade, and then it just shifts the cluster over. Yes. Or you can use the default, like for example, in DigitalOcean, you go onto the web for what is it, like the web page of DigitalOcean, and then you can upgrade your cluster manually. Or the same thing happens in Azure, if you want. Yes.
Have you open sourced this kind of automation in any way, or do you have plans for that?
Yes. The answer is yes. The whole demo that I'm going to show is open source, and so you can just take it down. I try to make a good documentation site, but you will be the judge of that if you are trying it out.
So what's the weak point? I mean, if something fails, where does it typically fail?
Where does it fail?
It can be that it's a software that doesn't fail. I haven't seen that.
I've never seen a software like that yet, but yeah. So there are a couple of, let's say, not rough edges sometimes. So Flux is in very early version at the moment. I've seen it get into a state that it needed some manual nudging to do what it needs to do. Generally speaking, other than that, it worked quite well for us. Now, one thing that you need to know is that in VTT we are not doing like these giant production releases that big companies are doing. So when we are doing a research project, we are talking about hundreds of end users, maybe a couple thousand, not like millions who are hammering the system. So your mileage may vary if you use it with real big amount of users.
So
Sorry?
There was a question there.
No question?
Okay. So I had a question about,
yes.
Doesn't it fail with Let's Encrypt and Ingress and that kind of DNS? Because when I'm
actually never had a problem with that. So one of the things that for example, why we chose Ambassador is that in Ambassador you can, during that step, already tell that where the certificate will be, even though it's not there yet, and it doesn't care. As long as it doesn't find it, it will not serve HTTPS, only HTTP. And when in this step, we are requesting the certificate into that name that we already configured there. It picks it up and then just starts working with it. And as soon as like Cert Manager rolls the certificate once it's almost expiring, Ambassador will just pick it up very nicely. That wasn't true for all the ingress controllers we tried when we tried it.
Yeah,
so
that's cool. I've been using Traffic, and that worked okay, but
yes,
still,
Traffic was a bit flaky for us also. Yeah. In case of Glue, which is also I think a really nice ingress controller, we had some problems with using their service mappings. So the thing that they have instead of the ingress component, it sometimes was not working. So this was the thing that was stable for us, and that's why we ended up with this.
Cool.
Okay, so very quickly, I don't know how much time I have, but probably about 10 minutes or so. And so let's...
Yeah, you're pretty good on time.
Okay. So this beauty is how it looks when you run Pulumi. So it has practically, it creates an object tree that this is what I will deploy. It will ask you, is it okay if I'm doing it? In this case, this whole thing will create 193 different kinds of resources into the cluster. So that's, and then it goes, as I said, about the way I demo or showed it on the screen. So it installs Linkerd, it installs Cert Manager. What else? It does, yeah, Cert Manager was there, and then it installs Ambassador, and then it creates the DNS names, a normal one and the wide one. It installs sealed secrets, and then once the DNS is registered, we create these in-cluster issuers. Configures both a production one and the staging one. By default, it uses the staging, but that's a configuration option. Then it installs Flagger. It installs this component called Flux Proxy. This is not in the usual one. I install it for this demonstration, so I can more easily show you what Flux is doing. This is something I wrote. But if you want, for example, notifications from Flux, there is a component for Flux Cloud, and it's nowadays they are moving it into the mainline Flux, so you can get your notifications in Microsoft Teams and Slack and some other places. It tells you what did Flux do to your cluster, practically. Yeah, so it showed me the plan, then it does the creation. These things that are visible here are the things that I told you that it really checks that the thing is created. It doesn't just dump the YAML file to the Kubernetes API and then hopes for the best, but it actually checks that did your pods come up? Do they crash looping? Then the whole deployment will stop at that point and give you an error, things like that. For example, for the load balanced services that the ingress controller uses, it waits until the external IP address is ready, so you can then move on and then actually use it. And then you can create these kind of outputs. This is something that you totally free to define. For example, one thing I like to define is this. This is the command that you need to run to gain kubectl access to your new cluster. So I already run this. Let's see a couple of things. So
one question.
Yes.
So now you're using DigitalOcean's managed Kubernetes, right?
Yes.
Do you use AKS?
Yes.
In other words, the Azure's own Kubernetes service?
Yes. In production in our company, VTT has a agreement with Microsoft, so we have to use Azure, and we are using AKS. Yes.
Okay.
Do
you know how much it costs? Is it free or?
No. As I said, that's one of the reasons why we keep the clusters separate.
The nodes cost.
Yes, technically.
That's what I thought. Yeah.
So it runs a master node for you.
Yes.
Yes.
So it runs a master node in an HA configuration, which you don't have to pay for.
Exactly. Yeah.
But you have to pay for your worker nodes whenever you run a workload. So
Yeah, exactly. Yeah. But I was thinking about the control plane because that's otherwise an extra cost you have to.
No,
if you're doing environmental, you have to pay for all the control plane things, which is actually in the cloud.
Yep. So this is that small component I wrote, and this is what kind of events you can get from Flux. It tells you that what happened when, what was the affected resource, and then this switching to sensitive mode I will show in a second. So I have this web application that is most awesome looking. The thing is that the original view of it looks like a metal band catalog, but it has this sensitive mode, so if we are doing this kind of more public presentations, then it can just show things that are. And what it does is it's practically a load generator for the services that I install in the system. And every time you see something red, means that something went wrong with one of the services. So, for example, the image URL didn't came, or there should be links for all the categories. So sometimes they show up, sometimes they go away. The application is written in a way that it should fail. So I can demonstrate, for example, how does it look in Linkerd when these kind of things happen. So how do you like debug your services? So let's start up Linkerd. And so how it looks like is so these are the namespaces, the success rate and things like that are, you can see here that what is meshed and what is not meshed into the service mesh. So you don't, one nice thing about Linkerd is that you don't need to go all in, that either everything is in the mesh or everything is outside of the mesh. You can quite gradually, as we saw, when you put that annotation on the namespace, that's when Linkerd understands that, okay, anything that goes into this namespace needs to be inside the mesh, so I can inject my sidecars to the pods. Everything else is left alone. So in this case, so you can see the ingress controller is meshed in, and then the VTT namespace, VTT hello namespace, my little component, and Linkerd itself is meshed in. One of the important things to think about when you create your setup is to select an ingress controller that can work with Linkerd in a mode that the ingress controller is also inside the mesh. Because otherwise, when you get a request, the first step between the ingress controller and, for example, my services in VTT would not get the MTLS encryption. So those would still be outside in the plane. So, and that's also one of those things that not all ingress controllers can be used. So at the moment, as far as I remember, Ambassador, Glue, Traffic, Nginx, and there is one more. Contour no. Contour is actually doesn't work with Linkerd in the meshed mode. The problem with that one is, actually Contour was the one that we used before Ambassador, is that when Linkerd does routing, it uses a host header that needs to point to the name of the service, and that is a header that you need to inject manually practically. For all these ingress controllers, there is a way to define some extra headers on the service definition that will be injected when a request goes that way. Ambassador is special in a way that it has a configuration option that it does that for you automatically. So you do it in the main config of Ambassador, and then you don't need to care about it in your service definitions. But normally you have to do it in the service definitions. And then the problem with Contour is that it doesn't support adding new headers to a request, HTTP request. So, as we can see, the web page is running in the background, and we can see that something is really not good in the VTT namespace where the service is deployed. So, when we go here, it will show a kind of image that how the services talk together. Practically in this setup, bands is the service that is exposed by the ingress controller. So the web client talks to that one, and then it tries to get the set of links and then a set of art locations practically, and that's what is displayed on the screen. And then you can see this kind of setup is because of art is using a canary deployment. So canary deployments are done in a way that there is one service that is the canary, this is that one, and then the primary one is where all the traffic is actually going right now, because we are not in the rolling a new canary scenario yet. I will try to show that in a second. So, yes. And then, as we can see, links is failing similarly. So, let's try to do the canary deployment. This will be the interesting part of this talk, if it works. So what I will do is, because we are using Flux, so we are using GitHubs, so I can do this using this page. Not bands, sorry. Let's fix art, because that is the canary one. So I wish all bugs could be fixed this easily. That let's call it fixing art. And we commit the changes. Okay, so now the change is in the Git repo. We would normally need to wait some time, because the Flux is doing, if I remember correctly, by default a 5-minute interval polling. So every 5 minutes it checks is there anything new in the repository. But it has a command line tool that you can use to nudge it into action whenever you would like to. And then it sees that something new is happening, and ta-dum, ta-dum. Yes. So you okay, so it already picked up the event. You can see we got a new event from Flux, and then it understands that the thing that I changed is this art deployment, and it shows the commit or all the commits that was picked up at once. And now we can check the canary in VTT. So we can see that that at the moment it's already started to do the testing. It will go in 5 percentage increments up to 50%, and it will finish within like 1.5 minutes for this demo. Normally you would of course let it run for a much longer period of time. And then if we go back to Linkerd, it has a really nice UI for the same information. So it shows that this is our primary, the canary is going up and up and up. Success rate is now 100% because we successfully fixed our bug. And as soon as it reaches the 50% line, it will decide that, okay, this canary looks good, everything is peachy. So then it will switch the primary over to the same version that the canary has. And from that point on, the primary version will be the new version, and then the canary version will be scaled down to 0. So it doesn't take up any of your resources in the cluster. Of course, for this to work, one thing that if we talk about failure scenarios, is that when you size your cluster, you need to have enough space for the canary also besides your primary. So you cannot have such a small cluster that it doesn't accommodate for that. Okay, so now we reach the 50%, and soon the status will change to promoting. So now is the time when it decided that, okay, I like the canary, and I will promote it to production and scale down the canary version. Okay. Sorry? Fail checks. Okay, so in the beginning, so you can define that how many requests need to be successful and within a given time period for it to be considered success. So this one could be two things. Either the service came up slowly, all these services are written in Java, so they might be might be that one, or the other one is that because in the beginning we, for example, sent only like 5% traffic towards the system. So because the web page is refreshing itself quite slowly, it might be that nothing actually went to the canary, which is also a failure, because practically the system cannot be sure that is the canary working or not. So that's why in like real life scenarios, you can create load testing routines and specify it in your canary. So when the canary starts up, then this load testing will target only the canary and bombard it with practically generated requests. So you can be sure that you're actually testing the canary for real traffic. In this scenario, I didn't set that up because of setting it up for gRPC is a little bit harder than setting it up for HTTP. Okay, as I said before, I don't have. So in case of gRPC, success rate is 100%, that's a surprise. So in case of gRPC, there is no support for retries. And the main reason for that is that at the moment, Buoyant, the developers of Linkerd, are reluctant to enable retry support for anything that might have side effects. And typically, like post requests do have side effects. In case of gRPC, every request is a post request. So because of that, it doesn't work. So what I have is this VTT hello is a very primitive version of the web page that you saw. So this was the first version. It just gives beautiful error messages, or if you are lucky, a nice JSON file. So it similarly has two sub services behind the main service that is exposed. One of them would generate a timestamp, the other is generating this big message, and both of them are set up with 30% error rate, so rather often they fail. I have a so this script, oops. So this is a load testing script using a tool called Artillery. It will create about 400 requests in 20 seconds. And you can see that it completed this much, and how many successes and how many errors. It should be about 50-50. And I created service profiles for these, so we can check that one. So this is, for example, how a service profile can look like, and as we saw actually previously already, and it now defines that the retry ratio is practically that says that how, if you count all the requests, what is the ratio that can be a retry. So in this case, I'm saying that even 50% of the requests can be a retry. The mean retries per second is something like a 3 retries per second that doesn't count against the ratio. And then the TTL 10 seconds is that what is the window within where the ratio is calculated. So this one, if we apply it nice and quickly, so now if we run the same artillery script, we should see about 100% success rate, because yes. Okay, so we had 400 requests, 400 successful. So this could be one way to fix your services in case you know that the requests can be retried. There is no harm using this. And one last thing I wanted to show on the Linkerd, the UI is, if we come here, so when you define your service profile, this is what you can get. So normally everything would go under this default service profile, so all the requests are in one big bucket and show your success rate. But if you create a service profile, then for each endpoint within your service you can define a name practically, and then you can see that not just that globally how is your service failing, but which exact route within your resource is the one that is failing. So that's also a very nice way to help you debug your system, and it was very valuable for us multiple times when we were working on the services. Okay, any questions? Yes, please.
On the canary deployment, like what happens if there is another commit and another deployment while there is still existing canary like rolling out?
I don't know, to be quite honest.
Okay, so it starts with the new version and still runs the old version.
Yeah, so it will start to make a new one and it will restart the whole analysis again. That's
Okay.
the old analysis is cancelled and
But that's still likely to be like an original one, so there's like a version 1, then you deploy version 2, which is deploying canary out, and then it goes like version 3.
So your real traffic is never completely moved. It's always the
Okay.
So your real traffic is never moved because they have different annotations. So they are completely still working.
Okay.
It's just the traffic is moved. So
Yeah.
once those canary instances are gone, an instance comes up, traffic is routed there. That's all. Your production instances never know or feel there's nothing happening there.
Anything else? Yes.
Where can we look at the source code of
Yes.
them?
So let's go back to the final page of this. And I guess we will be sharing the somehow. So
through Meetup comments.
okay. So this is the URL, and if we go to the if we go to the web page, because I heard during the break that somebody asked that how could he do this kind of everything from source code to deployment to anything. So this has practically everything except the source code for these primitive VTT hello things. So it has the API definition for the services, this documentation. This is again a site that is automatically deployed from the source code. You should have like layout, and for example, provisioning has all the options that you can set in this Pulumi script for stuff. And oopsie, this is not the one. So the GitOps contains the deployment scripts that we are using. I put it into a different repository because I don't want Flux. One thing that Flux does is it writes to your repository these kind of notifications that what did it actually applied to your cluster, because I didn't want it to put it into this base one. I created a separate repository, but the content of that repository is exactly the same that is in this GitOps directory. Then the Java is all the Java code. The provision is where all the Pulumi things live. The service profiles for the Java code. Then the deployment YAMLs for the VTT hello thing, and then this is a small web client that uses gRPC web and Vue to display those flames and red things and everything. And then if you are interested in CI/CD stuff, then this GitLab CI YAML is your friend, and it has all the build instructions, how it builds the Java code, how it packages into Docker containers, and all the containers are also available from this container registry that is built into GitLab. So you can access that. And in case you find bugs, which is likely, and and you have any questions or anything, then please contact me and we can try to improve it and use it as a...
I was thinking with the 193 like things that were applied by Pulumi,
yes.
And you said it actually worked.
Yeah.
That's really good.
I could show, so I was thinking actually, would it be cool? I actually started the cluster when I sat down when I arrived, cool. Yeah. But why I didn't want to do it live, that it takes 13 minutes to create the cluster and apply all these things. So it's like watching grass grow till nothing happens. So I thought that I use the pre-created cluster, but I run it yesterday evening like 16 times at home just to make sure, and it's practically a bit toned down version of what we are using inside VTT, just to make it a bit simpler. But as I said, hopefully it works. If you find any problems, please tell me, or PRs are welcome and everything like usual. Okay.
Any other questions? Well,
Thank you.
Very much. Awesome. We ended exactly at time. Very been packed and well scheduled. Just for the sake of it. Cool. So the question was if we've considered doing a open unconference or something like that. And yeah, so what I forgot to mention in my first presentation was that with this Cloud Native Nordics, we're targeting to do one of these Kubernetes days, kind of like the forums that we saw that CNCF is making. So a community organized conference. This is a really large undertaking, so it will probably take until October next year or November or something like that. Probably will be in Stockholm too, but if you're interested in helping out with organizing that stuff, go to cloudnativenordics.com and go to the Slack, and then you'll find all the information needed for participating. But it's a really good point that like until that happens, which is going to be some part unconference and some part scheduled, most likely it would be, yeah, it would make a lot of sense. It's a really good idea. What kind of did you think, like just a random date and just get people together?
Yeah, it's like we're scheduling these meetups, then just decided, okay, today we're going to do open spaces and then just make it happen.
Yeah, sure. We should fairly easily, I think, also find some venue sponsor pretty much wherever and just have some food and stuff meanwhile. What do you think would be a good time, like during workday or after workday or like even weekend, or what do people think for that?
I would vote, just the regular meetup style.
Yeah.
Work hours, couple of hours from 6 to 9.
Yeah, we could definitely just go ahead and schedule a meetup as is without any agenda. That's a really good suggestion. Hopefully we're gonna be able to do one of these Kubernetes 101 again fairly soon, to make people get more on the same level, and hopefully 102 or whatever at some point too. Yeah.
Of course, it will put some constraints on the space, because then we would need some breakout rooms and like that.
Yes. Yeah, we'll think about it. Exactly that kind of feedback we would like to get and also need. Sorry.
The 6th, there is this Zoom call thing that you can dial into.
Yes, good. So the Cloud Native Nordics thing, we have every first Wednesday of the month at 2 p.m. Yes, Finnish time. We have a public discussion with all of these things. Most of the organizers from Finland join, and then a lot of other people from the rest of the Nordics to talk about these things, like how can we make our meetups be better? How can we serve people in the way that actually suits them the best? So again, if you have suggestions, want to make it make it better, join there, or these kinds of fill in these forms, getting privately in touch with us if you want, or any other thing. More suggestions, feedback? Well, thank you for attending. Great to see this good turnout. And yeah, I don't know. Happy New Year, if nothing else. Merry Christmas.